Welcome to the Unit 3 Systems Review. Okay, this is the work for the unit review for Unit 3, which is Systems of Equations. Reminder, systems of equations are when we solve two or more equations at one time. The first two questions are super duper easy. The work is already done for you. All you have to do is estimate the solution of the system of equations using the graph provided. Give your answer in the form of a point. That's what we're going to be doing in this entire section, which is what we've been doing in the entire unit. So I'm looking for the point of intersection. These 2 points intersect right there, and that is the ordered pair 0, 2. Sometimes it's possible that our lines would not intersect if they were parallel, and that would be no solution, or they could lie right on top of each other, which would be infinitely many solutions. But these ones obviously intersect. Now this one is not at a lattice point, number 2, but it's just off of the lattice point. So let me mark it one more time, and then I'll erase it because I want you to see that this is just less than 4. So I'm going to say that's 3. Oops, that's a lovely 3. 3.6. And then over here is just a little bit more than 2. So I'll say 2.2. And I did have to estimate that answer. There's no way for me to know what that answer is exactly. But there you go. There's numbers 1 and 2. Now for the rest of them, I'm going to have to basically find that graph before I can find my solution. Number 3 and number 4 look really easy to do. They're both in slope-intercept form, so I don't even need Desmos for these. If I look at number 3, the first one is y equals 3x minus 7, so my y-intercept is negative 7. From that point, I go up 3 and over 1. 1, 2, 3, over 1. 1, 2, 3, over 1. 1, 2, 3, over 1. For these, I like to keep going as far as I can because graphing is the least accurate method when doing it by hand. So I like to keep finding points, and what I found is a lot of times on these problems I get one of those points to intersect. So looking at my second equation, my y-intercept is 3, and my slope is negative 1/3, which means I'm going to go down 1 and over 3, and there it just happened. There's the point where they intersect. Down 1 over 3, down 1 over 3. So I've now found my point of intersection, because you see my line's not very, I don't know, straight. It's kind of crookedy there. So, but I know that that point is right there, which is the point 3, 2. Looking at number 4, the first equation is really easy to do. My y-intercept is 7. My slope is 2, so up 2 over 1. Or I could have went down 2 and left 1, down 2, left 1, down 2, left 1. And there's my line. That's beautiful. And then the other one is a funky equation. How many people think that one's hinky? Yeah, a lot of hands went up. This is another way to write this equation would be y equals 0x plus 3. Do you see that? But I wouldn't ever write 0x, would I? That's just kind of stupid. So my y-intercept is 3, and then my slope is 0, which means it has no slope, and it's a flat horizontal line. So there's my point of intersection, which is the point negative 2. My mind said negative 2. My hand wrote negative 6. How does that happen? Negative 2, 3. Any questions so far? Wonderful. That's the end of the first page. Going on to the back page. Now, numbers 5 and 6 are not in slope-intercept form. I'm going to keep doing these by hand because I can. But you would most assuredly use Desmos, and that's okay. There's nothing wrong with that. But I'm going to keep doing it by hand just for fun. This first thing I'd do is I would add 2x to both sides, so I'd have 2y equals 2x plus 4. And then I would divide by 2 to get y equals x plus 2. For the second equation, I'll go to a different color here. I would subtract x from both sides to have y equals negative x minus 8. Now that I have those, I can graph them. Let me graph the blue one first here. My y-intercept's -8. My slope is -1, so I go down 1, right 1, down 1, right 1, or up 1, left 1, up 1, left 1. Okay. Beautiful line. My other one, which was in red, is y equals x plus 2. So my y-intercept is 2. I go up 1, over 1, up 1, over 1, or down 1, left 1, down 1, left 1. And there they are. There they intersect. And that point is -5, -3. Any questions on that? Now, I did all the work. I did it longhand, but still, as you can see, it's not a problem. Number 6, that top equation, the first thing I'm going to do is get rid of the fraction. How many people would do that too? Please pay attention, because a lot of you, I saw a lot of you do on the last unit test, try to do this, but you forgot something important. So I'm going to multiply by 3, right? Well, 3 times x is 3x. But what's 3 times 1/3 y? 1. Remember, when you multiply by the denominator, you get the numerator. So that's a 1y. And then I have to also do it to everything in the equation. So 3 times 2 is 6. A lot of people here, they ended up multiplying the top number. Now, in this case, so they ended up multiplying 3 times 1 to get 3, and they'd put a 3y up here, but that's not true. You get the denominator, or excuse me, the numerator. So don't forget that. Now I can subtract 3x from both sides to get y equals -3x plus 6. Any questions on how I changed that to? Whoa, that's really cool how that worked, but I don't want that. I don't want that. How about now? No. How about now? Oh, there we go. Yes. Yes. Okay. If you're given a graph and told to do it by graphing, and you do use Desmos, please just graph the lines, which you should have no problem doing, right? Second equation, I'm going to add x to both sides. So I have y equals x minus 10. Now I graph them. -10 is my intercept, up 1 over 1, up 1 over 1, up 1 over 1. The red one is, my y-intercept is 6. My slope is -3. So down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1. There's the point of intersection. You understand why I keep going on those points with this? Because I don't have a straight edge to make sure my lines are nice and straight. So my point of intersection is 4, -6. Cool? Moving on. Now, the cool thing about these ones is I get to choose the method I would use. And I'm going to use a method. I'm going to use substitution or elimination or something like that because I can. If you use Desmos, I'm not going to be mad at you. But if you just put the point down and you got the wrong point, well, you with no work, you won't get any credit. But anyhow, I would use, in this case, this first case, I would use the elimination method. And I'd multiply this second equation by a -3. Let me just rewrite this first equation. 3x plus 3y equals 9. And the second equation, when I multiply -3 times all this, I'd get -3x minus 3y equals -9. Cancels, cancels, cancels. 0 equals 0. That's true. Therefore, there are infinitely many solutions. Stop right there for now, and I'll pick back up in a few minutes. All right, so back at it. We're at number 8 here. Again, I'm solving these systems of equations using any method. I realize that you can use Desmos and you simply type them in, but that's too easy. I'm not doing it that way. I'm using a proper method for these. As I look at number 8, the first thing that I see is a fraction fraction in the second problem. I'd like to get rid of that fraction because I know the majority of you would as well. How do I get rid of fraction? I multiply by the denominator. So I'm going to multiply this thing by 4. 4 times 1/4 is a -1x. Remember, when I multiply by the denominator, I get the numerator. Some people got that in the last unit. I was really impressed that how many people were trying to get rid of the fraction multiplied by the denominator, but a lot of people still multiplied it times the numerator, but you don't have to do that. When you multiply the denominator, you get numerator. I've showed that a few times and leave it at that. So 4 times 2y would be plus 8y, and then equals a -44. All I did there was get rid of the fraction. Now I can see that if I compare these two equations, I'm going to go and write this one down on the bottom. So I have x minus 2y equals 8. I can see that I can use the elimination method or the addition method, and my x's will cancel. So then 8 minus 2 is 6y, -44 plus 8 is -36. Oops. 36 divided by 6 on both sides, y equals a -6. Now what do I do with that y? I plug it back into the original equation. I'm going to use the top one. So I have 2x minus 2 times -6 equals 8. So that becomes 2x plus 12 equals 8. Subtract 12 from both sides. 2x equals -4 divided by 2, x equals -2. That solution is -2, -6. You can check that on Desmos. Number 9. What should I use number 9? Anybody said substitution? Genius. All I have to do is substitute that 5 into the second equation. So x plus 5, always put a parenthesis around it, equals 4. Subtract 5 from both sides, x equals -1. So my solution is -1, 5. Just Staples easy button right there. That was easy. What method would we use for number 10? I would use the elimination method. This first equation, I'm just going to rewrite over here. 6x plus 2y equals 8. I think if I multiply this thing by a -2, I get a -6x, and my x's would cancel. You see that? I hope so. So -2 times 3 is a -6x. -2 times y is a -2y. And -2 times 4 is a -8. Uh-oh. Look at these equations. It cancels, cancels, cancels. So I end up with 0 equals 0. Is that true? Yes, 0 equals 0. Therefore, there are infinitely many solutions. Looking at number 11, I can make my x's cancel if I multiply it by a -2. So I get -2x minus 2y equals -2. X's cancel. My y cancel, so I'm left with 0 on that side. And 4 minus 2 is 2. Does 0 equal 2? That's not true. Therefore, there is no solution. On number 12, since one already y equals, I'm going to use the substitution method, substitute the y. So I have 6x minus 2 times 3x minus 5 equals 10. Distribute 6x minus 6x plus 10 equals 10. Those x's cancel, so I have 10 equals 10. Is that true? So therefore it is infinitely many solutions. Any questions on those? Next page. Now, here's the word problems. This is the one that I believe everybody has a little bit of difficulty with. Okay? So let's take our time. I know I'm going to have to come up with 2 solutions, or 2 equations, excuse me. Kara sells glasses of Kool-Aid, call that X, for $1, and lemon shake-ups for $3 each. I'll call that Y. One day, she sold 10 more lemon shake-ups and glasses of Kool-Aid. She made a total of $190. This is one I think is difficult because they took this information and put it at the end of the second sentence. If this information had been right here at the end of this first sentence, I think it would have been a lot easier. Let me reread the first sentence. Kara sells glasses of Kool-Aid for $1 each and lemonade shakers for $3 each, and she made a total of $190. Doesn't that make more sense? So I'd have 1x, or just x, plus 3y. Why 3y? Because I don't know how many lemon shake-ups she sold, but I know she got $3 per, right? So that means I multiply. And if I add those two amounts together, I would get $190. There's my first equation. But it became difficult because I took that information and put it on the end of the other sentence. One day, she sold 10 more lemon shake-ups. So, then glasses of Kool-Aid. What would that equation be? 1 equals 10. She sold 10 more lemon. Y equals x plus 10. How many Kool-Aids she sold? She sold 10 more lemon shake-ups. So y, lemon shake-ups, equals x plus 10. Now I have my two equations. Now what do? Well, I can use any method. If you had Desmos, you could plug it into Desmos. But keeping with the theme, I'm going to keep using the regular methods. So I'm going to substitute. Oops. I'm going to substitute. Oh, undo. There you go. I'm going to substitute this value in for the y of the other one. So x plus 3 times x plus 10 equals 190. So x plus 3x plus 30 equals 190. 4x equals 160. See, I did two steps there at once. Divided by 4, x equals 40. So if x equals 40, y equals 40 plus 10, or 50. So my solution is 40 Kool-Aids and 50 lemon shake-ups. Cool? I know sometimes I make that look easy, but I know it's not. Let's look at number 14. The perimeter of a rectangle is 14 centimeters. Well, how do I find the perimeter of a rectangle? I take my length, and my width, and my length, and my width, and I add them all together. So that ends up being 2L plus 2W equals 14. The length of the rectangle, length is, it is what? 4 more, plus 4, and twice the width, W. There we go. Now I can substitute this value into the L of the first equation. So 2 times 2W plus 4 plus 2W equals 14. Again, if you had Desmos, you could just plug those two equations in, substituting x and y for W and L. It'll be just fine. But 4W plus 8 plus 2W equals 14. Or 6W equals 6, W equals 1. So 2 times 1 plus 4 is 6. So our W, or L is 6. So our length is 6, and our width is 1. Cool. Number 15 is a mixture problem. Okay, these mixture problems, I think, are the hardest. Okay, please pay close attention to the last two well, at least number 15. It's a mixture problem. I know there's going to be one of those in that test tomorrow. Okay, there's a mixture problem. Mixture problems can be these percentages, or they can be like price per unit or price per pound. That's another mixture problem. Watch what happens. I have 12% brine solution. It was mixed with a 16% brine solution to produce 15% brine solution. How much of the 12% and how much of the 16% were used to produce a 40 liters of 15% solution? Now, those percentages I know mess with your heads. I don't know. The percentage is important in my first equation. I'm going to call this one X and this one Y. I don't know how much of the X I have, and I don't know how much of the Y I have, but I know if I add those two together, whatever they are, I'm going to get 40 liters. And I'll tell you, on the majority of these mixture problems, that's what one of them looks like. It's not always, but the majority of the time you end up with X plus Y equals the total amount you had. Okay? So now, this X value only has 12% brine. So that's going to be 0.12X. And then this second one has 0.16Y. And then that'll equal, I want it to be 15% brine, which would be 0.15. But here's where these mixtures become difficult. It's the last step that's only necessary on a mixture is I got to multiply that 15 times how much of the solution there is. And there's 40 liters. That's the step that everybody always forgets. Okay. Now, what method would I use? I don't know. There's a lot of decimals in here. What method do you want me to use? I'm going to need a calculator. Let's go ahead and tell you. Somebody got a calculator, get your calculator out. I'm going to need it in a second. Let's go up here to this top one. Let's solve it for y. So I have y equals negative x plus 40. And I'll take that and substitute it for y in the second equation. So I've got 0.12x plus 0.16 times negative x plus 40. And that equals, what's 0.15 times 40? 6. Sweet, thank you. So now I get 0.12x minus 0.16x. 0.16 times 40. Plus 6.4. Right, so 0.12 minus 0.16, 0.04x. And that equals 0.4, negative 0.4. Divide by 0.04. Divide by 0.04. X equals, sorry, that's a negative. Divide by negative. What is that, 100? 0.4 divided by 0.04. They're both negative, so it's going to be positive. It's okay. Just 0.4 divided by 0.04. I believe that's 100. 10. Well, it's 10. So x equals 10. So now I plug that back in. So 10 plus y equals 40. So y equals 30. So my solution is 10, 30. I'll finish this and post it on your Google Classroom for you. Let's see if we can finish this review now. Number 16 is a word problem. I know word problems are the most difficult for us students. So please pay attention. We'll do our best. Okay. one customer purchased 2 lattes and a hot chocolate for $9. This is about as straightforward as a word problem as you can get. One customer got 2, I'll call lattes L, and hot chocolate I'll call H for hot. So 2 lattes plus 1 hot chocolate for $9. The next customer purchased 2 lattes and 3 hot chocolates. 2 lattes plus 3 hot chocolates for $13. There's my 2 equations. There's my 2 equations. Now, what method would I use? I realize that you guys have Desmos, and you could then plug it into Desmos, and that's fine, but I've been doing all of these using one of the methods. So I'm going to use the elimination method. I'm going to take my first equation and multiply it by -1 because that would give me a -2L. So I'm going to do that, and I'm going to put it down here on the bottom. So that's a -2L minus H equals a -9. Now I'm going to add those two together. My L's cancel, which is what I want. 2H minus 8, or excuse me, 3H minus 2, or blah, blah, blah. Let's try that again. Slow down. 3H minus H is 2H. And that equals 13 minus 9 is 4. Divide both sides by 2, and H equals 2. Now I can take that H and plug it back into one of the original equations, the top one in this case, get 2L plus 2 equals 9, or 2L equals 7. Divide by 2, L equals 350. So my lattes are 350. Figures, they would cost more, highfalutin latte. And the hot chocolates cost $2. Cool? Let's go to the last page. The last page, systems of equations by graphing. Earlier I hit some button and it amazingly split my screen. And I don't know how I did that. Boy, I wish I could find that.
It's the control, and then the 3 little, captions.
I don't know. So I'm going to have to do it the old-fashioned way and split screen. Mr. Abel knows how to split screen really fast.
Yeah.
I'm going to have to go see him. Amazing how the young teachers know everything when it comes to technology. Like they grew up with it. Like when they were kids, they didn't get hit in the back of the head with a shoe by their dad and saying, "Turn the channel." You guys don't know what I'm talking about, no?
Did that happen to you?
Yeah.
Wait, Grandpa hit you with a shoe?
Grandma would hit me with a shoe. Grandpa would use his belt.
Sorry, at least you didn't get hit with a broom.
With a what?
A broom?
Oh, yeah, I did. All right, so the only way to solve systems of inequalities is by graphing, and there's no sense in doing anything other than just using Desmos here. So 3x plus y is, this thing's got to go away. There it is greater than -2. And there's my equation. I got to do one more. 6x plus 2y is less than 8. Oh, look. That's cool. Look at these lines. They're actually parallel. So it's the middle section. So I would need to, please stop talking. So I would need to graph those points. I got 0, 4, and 1.3333. And that's a dotted line. And it's shaded below. And then I've got 0.6666 and -2. And again, it's a dotted line. And it's shaded above. So it would look something like that. Now, given that in the rest of this review, the remaining questions are basically identical to that, and you would use Desmos, I'm going to stop at that point. Any questions on the review? Good luck to you on your test tomorrow.